So we are going to quickly show you how's it going, what the demonstration will be showing, and then we'll get into the demonstration. Next up, please. So we thought that one of the things you might be interested in is figuring out where we've been spending your money, and how much work is still needed on the components. So click the Data Explorer. That is currently in initial design phases. I think that we understand how we want to progress with it, and we're quite interested in that. It's an idea that occurred to us that I think will bring significant value to the radio and FEMDI projects. Next, we have what we're calling the developer portal, which, as you'll see, is the mechanisms by which people can authenticate and self-serve and get access to the data that they need when they're registering. That is in prototype right now. It works. I wouldn't have it operational because it doesn't have all the bells and whistles needed. And then finally, we have API gateways and the mechanism that we're managing those, that identity and access management and Key Vault. It sounds so impressive, but it's basically where we store secret things like passwords for administration and so on. All those things are validated solutions, and we're pretty happy that they are good to go for minimum viable product. So next. So what we're going to do here is we're going to show you what you've done. As my construction man says, we're going to look under the hood and you can admire. These aren't, thank you, Jane, these are not my words, but you could admire. So just as an aside, you met Clement, you did a communications workshop, which encouraged people to use more emotive language to get points across. And Jane has been enjoying asking ChatGPT, how should I turn this dry technical nonsense that Jeremy normally speaks into things that other humans might appreciate? And this is where we're at.
So the training was successful.
You can be the judge of that. But yes, I think it was successful. So here's the work we've been doing. Jane has identified that sometimes this may be a little uncomfortable because we're going to dip into some technical things because we have to show you technical stuff, because good technology often happens when you can't see it, is my opinion. And that's kind of the case for the FEMDI community components. It's coined as the boring brown stuff that nobody sees, few people understand, but if it wasn't there, you'd be upset about it. So let's move on. Let's right. Okay, so I'm just going to talk about the local components so that we understand what we've got. The first box here is persistence. So all of us will need to be storing and managing our data. Then we will process it and to make sure it has the right data quality, to make sure it's in the right formats and so on and so forth. For WIS2, you need a local broker so you can publish notifications about new updates to data and metadata. And in fact, in our demo, we've got that happening. We've got the notifications being published by both Denmark and Poland. So they're well on the way to understanding how they're going to interact with WIS2. We have metadata management to create, publish, and maintain the discovery metadata. Those are the information that will then be published into the global discovery catalog. And we'll show some tools about how you might be able to do that. And then data access. So with WIS2, you could just publish files and make that available. That's pretty similar to how we do it on the GTS today. We publish buffer files or grid files. FEMDI is trying to get us to use interactive services because we feel that they offer better mechanisms to engage with data, particularly large data. So next. When we look over into the brown, boring stuff, we have a number of components here. So the Data Explorer extends a piece of software called GeoWeb, which is a collaborative open source project being run by Finland, Norway, and Netherlands. Mikko is going to talk about that in a bit. It also will pull in information from the discovery catalog so that we can find out the data that's available, and we will pull in supplementary information from places like Oscar Surface so that when you are browsing through that, you will be able to find all the information pertinent to the data that you're exploring. Next. The API gateways themselves, they are published, deployed onto the platforms commonly used where the local components are. So for example, if your data access services are on AWS, then it wouldn't make sense to have your data go off AWS to the European weather cloud where the gateway is and then be served from there. So we've designed the system so that we can deploy API gateways to those platforms that are commonly used. EWC, AWS, Azure, and maybe Google Cloud Platform, maybe others, they could come. But we've chosen Apache API 6. It's open source, it's designed for the cloud, and we can package it and deploy it where it's needed. Next. We are using, actually we make quite extensive use of GitHub. It's not just a tool for nerds. It is a mechanism that allows us to execute actions. So when we make configuration changes, we can propagate those changes, do some automatic software updates, and then get configuration changes pushed. So we're using GitHub Actions and workflows in order to automatically configure the gateways. More on that later. Identity and Access Manager. So sometimes we like our users to register so they can access the data. We are using open source software called Keycloak to manage users' credentials. We don't manage people's passwords. I'm going to come to that in a moment. Number 5, please. We've developed a developer portal, which is currently in prototype mode, which allows users to register for access and get their API keys, revoke them, renew them, various other things. It's a simple web application. It doesn't do very much at the moment, does just enough. Next, third-party identity providers. So when you log into the developer portal, let's not create a new username and password because nobody needs any more of those. So we are using third-party things. The demo shows us using GitHub as a third-party identity provider. Others could be Azure AD from Microsoft, or it could be an OpenID service provided by one of us as members. In the FEMDI ecosystem, we can tie all these things together and create a federated trust network of identity providers. Sounds very grand. Just agreements that things work together. And then finally, we have a key vault so that when a user logs in and they request an API key, we store the API keys in a secure place, and that's called a key vault. We're using something called HashiCorp Vault for that, which is mostly open source. I mean, they did change their license to a business source license, but anyway, details. We can pick it up and deploy it where we need. So those are the components. Let's go on to the demo itself. Okay, so okay, so color schemes, they stay the same. So green is the local components, brown is the FEMDI community components, and then blue is the Wiz2 stuff. We have 5 data supply endpoints. Again, I just will say that Rodeo Work Package 2, that's the FEMDI work package. It's designed around building the community components, and that's what we're demonstrating now. But we need data to pass through it. So because we're running ahead of Rodeo Work Package 3 and others, we have got 5 data services from members, 5 existing data services to demonstrate the capability that we have. When Work Package 3, which is real-time metadata, or ESO, as you might know it, that's expected to deliver its first data services in March. We will configure these into our system. and then we'll add services from other radio work packages when they come online. The Data Explorer is in its early stages, and right now in the demo, you're going to see it as two separate applications. The Data Explorer will provide a user interface that leverages the Global Discovery Catalog's metadata API and members data APIs, and eventually pull in data from things like Oscar Surface. Oscar Surface is the WIGOS observation capability metadata managed by WMO. It tells us all we need to know about the stations that we're managing. It might even be useful if the Data Explorer was able to subscribe to real-time notifications from the brokers, the global brokers, so that things could be updated. But using all of this information, the Data Explorer will provide an integrated workflow. I love that phrase, an integrated workflow. Basically, it will be simple and support people from discovery of new data all the way through to how to visualize it and provide users with the URLs that they need for routine downloads and subscriptions that they can then put into their operational systems. Not quite yet, not yet. Can we go back? You'll spot here that this demo is using the API gateway is on the European Weather Cloud, and we're aiming to avoid unnecessary data movement. So we've tested our systems on AWS as well, but I'm not going to show you any data which is being served via an API gateway on the Amazon Web Services. Okay, let's go. So in terms of demo content, we're going to do it in 4 batches. We're going to start with actually searching, browsing, previewing, and seeing some data, because this is all about data and the rest of it is hidden infrastructure. Number 2, we're going to look at some notifications and how you can subscribe to real-time data. Then we're going to have a look at some authentication and access control, and then we'll get into some FEMDI management type stuff itself. So at this point, I get to take a break. You get to take a break from my voice, and I'm going to hand over to Mikko. Are you there, Mikko? Right, okay. So I would just say that this wasn't the demo problem I was expecting.
It seems that Mikko is not here, in fact.
Okay, so right, I'm going to Jane, perhaps if you can ping him and see where he's at, but I'm going to try and carry on and cover the stuff that he was going to do. Let me see how I can do that. Right, okay, so we're talking about the Data Explorer because we want to be able to see the data coming through. We are going to show you how we're going to discover data. We're going to look at these. Each of our 5 data supply services are supporting APIs. 4 out of 5 of them are supporting the OGC API EDR, that's environmental data retrieval. And you can already, and then we can browse through what are called collections to see what parameters and what data is actually available. For this part of the demonstration, this is all unauthenticated access. So, so there's no API keys involved. We're going to visualize some data at time series at a point. Sometimes, if Mikko was here, he'd give you an extension.
Jeremy, Can
Hello,
I just, yes, because I'm in the Slack with Mikko and asking where are you? So he just had his Teams crashed and he's getting back. So just a couple of minutes, but you can go on if you want. But he should be here.
No, sorry.
Yeah.
Wow. Okay, so I was just bigging you up.
Okay.
To say that in the middle of the slide here, we've got some emojis about seeing what mess we're getting into, because we haven't yet standardized how everybody's agreement on how we use the APIs in the same way. So over to you. Feel free to start from the top of the slide as well if that makes you more comfortable.
No, that's okay. We can move to the next one, which is the Java.
Yeah, just before, there's I think it's important that we recognize that at the moment, as we're going through developing the other work packages in Rodeo, and we're seeing how people are implementing EDR across our 31 member states. We are seeing people choosing different ways, different control vocabularies, different way to interpret the standard. And so we will run a piece of work on creating standard vocabularies for use in these APIs, and we will work with current data suppliers to develop profiles of EDR. Probably will work through the Open Geospatial Consortium's MetOcean domain working group. We will set up test beds, and we will be able to provide minimum requirements to say, if you want to connect your API into FEMDI and for it to work in a consistent mechanism, you need to follow this pattern. So that's a piece of work which will kick off in the next quarter. Mikko, I'm going to hand it back to you now, and I promise to be quiet for a bit.
Okay, thank you. And the point that Jeremy mentioned, I will show also one of the slides of the video. What are some of the challenges related to that? Unfortunately, I didn't hear about the introduction by Jeremy, but to demonstrate what we have done in FEMDI and Work Package 2 in Rodeo project, we decided to use GeoWeb because most of the work is technical, invisible stuff. If it's done correctly, users don't really see it. So we need a way to visualize it for you. And the GeoWeb is a project by Finnish Meteorological Institute, KNMI and Met Norway. We started it in 2020. It was already an ongoing project by KNMI, and they invited other institutes to join. And the purpose is to develop a next generation modern workstation that is based on the standard APIs and modern web techniques. Currently, it's 3 members, but it's open source project, so it's possible to join either in open source capability, or if someone wants to be full member in the GeoWeb, it's possible also. In that case, they must commit certain amount of developer resources to it. So it's a web application to visualize and analyze basically any georeferenced data. We have a demo environment available in the address that you can see in the slide. It's also a framework to build other web applications. There are a couple of examples. Currently, Finnish Meteorological Institute is renewing its external customer portal, and similar work is ongoing also in Met Norway. And they are using some of the components that are developed in GeoWeb. So it's meant so that you can take the components that you need in your web application and use it from the GeoWeb framework. The license for GeoWeb is very free, Apache 2.0 license. Like I mentioned, it uses the standard international standards to get the data from the backends. Currently supported ones are OGC web map services and new addition EDR, which is now demonstrated here in the FEMDI project as well. One notable thing is that each of these institutes, we have our own data engines and data APIs that supports these standards. So the cooperation is purely on the front end side, and the data engines that we use are developed internally. Although all those are also open source projects, but it means that we have at least 3 different set of implementations for these standards, and it kind of guarantees that it's pretty interoperable, because out of the box we have to support 3 different implementations. But of course the standards are here for that purpose exactly. The advantage here is also that it brings resilience. So if our internal systems goes down, we can use either the services provided by, for example, UMETSAT or European Center, or let's say that the Finland have some problems, we could then switch on and use Med Norway's backends as a backup. And of course, there's a lot of different data sources that can be visualized there, in addition to meteorological sources, and we can take use of take advantage of those as well. GeoWeb is lightweight also. You can use it basically with any device with a web browser, even with tablets and mobile phones, although the screen is not really optimized for small screens. And one of the reasons behind this is that, like everyone knows, the data sizes and amount is huge, and it's our current workstation is handling the data on the workstation, so that becomes impossible. But now that GeoWeb is just a web client and all the data resides on the back end, so we can take full use of resolution and both spatial and temporal resolution improvements. It's also built modular so that each institute can use those modules that they need, so it's possible to configure needed modules and disable the modules that are not needed. That's a short introduction to GeoWeb that I'm using now in the demonstration, and if anyone is interested, you can let me know if you want more information about GeoWeb. You can switch to the next slide. So in the first video, I will show FMI backend, and there we use European Center data. So in FEMDI, we have the FEMDI gateway that allows access to data suppliers. And in this demonstration, we have configured 4 different suppliers: Denmark, Finland, Netherlands, and Norway. And currently, there's not that many clients that can do EDR visualizations. So in this demo, we use GeoWeb. And in GeoWeb, the support is currently somewhat limited. Currently implemented is time series support. So depending on the backend, you can click on the map, either on the predefined positions or any position, to get time series from the selected data and the parameters on a time series. Later this year, we have planned for map support, so you can plot, for example, observations on a map. Currently, it's possible to use GeoWeb to explore the APIs, in this case, the FEMDI gateway. So we can see what type of data to which area is available. So if you play the video chain, in this case, I will select a couple of parameters from the FMI service. So I cannot point here, but now I click the round thing that says FMI. So that's the FMI backend through the FEMDI service. And then I selected the collection. So the collection is one type of data source, in this case, the European Center data. And I can browse through which parameters are available. And now I selected temperature and pressure to the plot. You can obviously have as many parameters as you want, and you can mix and match different backends, whether it's the data from Norway or Finland, and then choose what type of visualizations you want to have. Also, it's possible to select the model run if the data is that type of thing. Also, the backend provides predefined positions in some cases, like in this case. In our backend, it's also possible to click anywhere outside of the points to get the data to exactly that point, but it depends on how the backend is implemented. So this is also one of the things that Jeremy mentioned earlier. When we implement these backends, we should agree on certain minimum set of things that we implement so that the backends would work a similar way, regardless if I'm using data from FMI or Norway or Denmark or whatever country. And the other challenge is on the right side of the screen, you see the parameter names. In this demonstration, you probably noticed that in each of the service, the parameter names are different. And currently, they don't have meta information attached to it. So it's sometimes difficult to know which parameter is which, but especially between the services, it's difficult to know if this is the same type of data or not. So this is one of the work that needs to be done when implementing these backends. Then I think we can move to the next video. In this case, I will select the Met Norway service. On the top, you can see 3 different collections. The collection names, once again, they are not standard, so it can be anything. In some cases, difficult to know what it is. Now I selected wind speed to the upper plot and changed it to bar plot. And now I will change the model run as well. There's a meta information window implemented, but it is not fully implemented yet, so it's missing a lot of data, only the basic information about the layer or the parameter. In Met Norway's case, it's not possible to interpolate anywhere in the map, so you have to use the blue dots that you can see on the map. But that's also provided by the backend, so that part is luckily standard. So the backend will let the clients know what is available and to which locations. And that's one of the strengths of the EDR. Then in the last video, don't play it yet, but you can switch it to already. I select KNMI service that has surface observations on it. If you can switch the slide, but don't play the video yet. In this case, I have this kind of a developer view in my browser open on the right side. The reason for that is that you can see a couple things there. I will highlight it with my mouse when the video plays, but you can see that it, even though the data is located in KNMI backends, it goes through the FEMDI gateway, and the FEMDI gateway is there to protect the original data sources and provide things like rate control and different user classes. And one of the things that you can see from the developer view is the rate limiting. So when this application requests the data from the backend, it's using the free or unauthenticated user class, and there's a rate limit for that. And the counter in the developer view goes down. I will point it out once the video plays. But first, let's play the video chain. And in this case, I once again open the time series manager and select the Dutch EDI service. They only have one collection called observations. And here you can see again the parameter names are different. I think I selected the dew point temperature. These are the observation stations that are available. This comes from the backend as well. So here you can see the dew point temperature, and I select a couple different observation stations. You can do it either by clicking on the map or through the drop down here. Now, if I remember correctly, I will, from the developer tool, here you can see the query that it does on the backend. So developers that use these FEMDI services, they can use these to query the data and output it in their own application. And now I highlight the rate limit. You can see that the rate limit is 1,000 queries per minute. And the counter is going down when I do new clicks. And these rate limits are there to protect APIs so that there's not excessive amount of queries to the APIs that could potentially overload the data suppliers' APIs. There's a different user classes that can have a different type of rate limits. For example, the UMetNet members could have their own class that has a different quality of service. This concludes my demonstration. As you can see, it was mainly the visuals were through the GeoWeb, even though that is not FEMDI work as such, but we need a tool to demonstrate the FEMDI work because it's quite invisible for the users. It is very much visible for the developers, but for the end users, it's not visible as such. Here we have a couple slides more. This is a software product called QGIS, which is a very popular open source application that can be used to visualize and also manipulate georeference data. and there's a very new plugin for it that supports EDR APIs. And in these screenshots, there's the address in the top of the dialog there is to the FEMDI gateway, but in this case, the Danish data. And this is from the one model, wave model, and it displays the data for certain selected box. And I think there was another example. If you go one slide more. No,
I think that one's still hidden.
Okay. But this was example of another application that can use this data as long as we use these standard APIs. Yeah, this was the other hidden image. This is from the Finnish API. In this case, the query is done so-called radius query, which means that it's a point with a certain radius, and you can see the grid points from the, in this case, I think it was Silam air quality model. So you can see the grid points. The visualization is a little bit different, but the idea is same, that through these APIs you can query the data into area that you are interested in, and those parameters and those data sources that you need in your, whether you are developing a new application or are doing research and need data for that type of use case. That's it. Back to Jeremy.
Thank you very much, Mikko, and commiserations on Teams crash at the perfect moment.
Yeah.
So just a note on that QGIS plugin. That's something that the Met Office team have. We've provided a bit of funding to get that EDR plugin done, because it helps the community if there are more clients around that can consume the data that we're doing. So if you want to find out more about that QGIS plugin, please drop anyone from the Met Office team a call, and we're happy to put you in touch. So let's go back on with the slides. Right. Okay. So Mikko, great presentation of GeoWeb. Somehow magically you knew the data URLs to use, Mikko. How did you know that? Well, you knew that because I told you beforehand, but if you didn't have a Jeremy available, you would have to have a different means for doing things. Next slide, please. So this is where the Discovery Catalog comes in. Now, if you remember when we started, I said that our Data Explorer would provide that seamless interface from discovery through to data investigation. Right now, I'm going to show you a bare bones user interface that's provided as part of the global catalog itself. That Global Discovery Catalog is hosted by Environment Change Canada, hence the Canadian flag. It's still in experimental mode to support the pre-operational phase of WIS2. But it's better to think of the catalog as two parts. If you can just click, please. So the first part is a metadata repository where all the discovery metadata records are stored with a standard API. In this case, it's another OGC, Open Geospatial Consortium API, called OGC API Records, to query that repository of records. And then second, we have here a bare bones interface allowing, no, if we can stick where we were. Thank you. Bare bones user interface allowing humans to search through the catalog using a web browser. The repository thing will also allow indexing by search engines, so people can find data through Bing and Google as well. So from a FEMDI perspective, we need to use the first part of this, the catalog, the repository and the API. That's the important piece for us. The Data Explorer will develop a new user interface, probably as part of GeoWeb, that allows users to browse the catalog. Mikko said that GeoWeb is modular, so probably we'll create a new module that supports this kind of activity. And that will support keyword searches, free text searches, spatial searches, whatever, to allow you to find data which is relevant. We'll also, you can see at the moment, the catalog is showing data from outside Europe. Gosh, I mean, who knew there was data from outside Europe? We will likely provide optional filters so that people can just toggle it down and show only FEMDI data. Now, unfortunately, we're still shaking out some bugs in how metadata propagates through that pre-operational WIS2 system. So that's all outside the control of the FEMDI team. So the rub is that all the metadata that we prepared to go into the catalog to browse through is currently sat in limbo in somewhere in WIS2, but hasn't made it into the cache. Hasn't made it into the global catalog. I'll show you how the metadata is published later, but for now we only have some older metadata, discovery metadata provided by the Institute of Water, Meteorology and Water Management from Poland. So you can see on the screen, I've selected that record. It's Poland surface weather observations. So if you click, please. Okay, so this is the HTML. Right. Okay, perfect. So this is the HTML rendering, or the web rendering for humans of what we see. We have a bounding box. We have a whole bunch of useful information, some of which are links which I could click on and follow. But there is so much more detail in the machine readable version of this record, and it's that machine readable record that the discovery, the Data Explorer is going to be using. So to illustrate what you can get out of a discovery metadata record, and I need you to help with imagination that we're creating a seamless experience that will allow, as a user, to browse through this information and get the data that you need, get the information you need in a as and when you need it, rather than be overwhelmed. We're going to use data that would have been metadata for the Netherlands data set that Mikko was demonstrating earlier. So that's 10-minute obs. Next. So if we clicked on the JSON button, this is Jane. You should have put a warning slide on this. This is like super tech, right? But I don't need you to read the JSON. All you need to know is it's a standard format. It's GeoJSON, OGC API record standard, and WMO supporting it as well. And it allows me to say useful things like where the data is, the spatial extent, identifiers, titles, descriptions, who to contact as the publisher, keywords that I could search on. It tells me where the URL is of the data supply service. And so that's the URL that the Data Explorer will use to feed into the stuff that Mikko was showing us earlier. This particular example has got some raw download files. And for those eagle-eyed people that are really looking, you might notice that the data supply service is through the API 6 gateway, but the raw data download is through the Netherlands API that would probably need an API key to access. We can also see that there's an MQTT subscription endpoint. So I could subscribe to real-time updates for the data. Caveat, that endpoint doesn't respond because I added it. It doesn't exist yet, but we will all need to provide these real-time update things. There are links to Oscar Surface in this metadata. So Gisbert, who prepared this, he created a URL that links to all of the surface stations in Netherlands. I'm going to show you that in a minute. There's links to the API documentation, the license and the citation, which are of course super important because we need to know when and where we can use the data. And when we use data, we all need to remember to cite it so that we get the right credit to the people who publish the data. So this tells people how to cite the data. Next, please. And this is actually the link into Oscar Surface. It links to the machine readable thing on the right-hand side. So you can just imagine that if I'm clicking through my Data Explorer, now I'm able to dig into the metadata about each observation station, and then we can we can link that into the data or link it with the data, which is being returned from the collection metadata on the EDR endpoints. I said a lot of words there, but just imagine we find all the information out that we need to interpret what data is coming back to us. Okay, next, please. So we also talked about real-time notifications. I'm just going to show you how that might work. Here we're going to see notifications being generated by data supply component. In this case, I'm picking on our friends from Denmark, and those are being published, taken on board by the global broker, and then we're going to subscribe to those real-time updates. So this is how we will be getting our data in near real time shortly. Okay, next, please. So I'm using an open source tool. It's called MQTT Explorer. There are many MQTT clients. It's an open standard, but this is just a freely available one. So you can see here are the details for connecting to the Métier France's global broker. You can connect to yourself if you like and have a little browse through. The password is everyone, and the username is everyone, because it's kind of for everyone. So if we go to the next slide, please. You can see here are the topics. This is the topic structure up in the top left-hand corner, and we have the WIS2 standard topic structure, and it gets all the way down to surface-based observations. And it's a bit difficult to see, but as of after a few hours yesterday afternoon when I took this screenshot, we had 44,713 messages provided to me by the Danish endpoint. So they're very rapid in telling me that there's lots of bits of data that I could get and download. And 44,000 sounds like a lot, but actually it's not very much for a machine. Machines can deal with those kind of things. It will be a problem if I was expecting a human to read each message and respond to it, but all of this is automated. Next, please. So here you can see we're subscribing to that topic on the global broker, which we know. So each publisher publishes to their own topics on a certain thing. Data consumers subscribe to that, and then they get the messages such as this JSON-y bit in the middle. Then they read through the message or parse it to find the URL from where the data itself is downloaded from. And right now you have a bunch of software choices to do this. There's open source WIS2 Box, or I know that IBL Moving Weather supports this, and I'm sure there are more. But it's pretty standardized stuff. If we go to the next slide, please. So here we see, I'm looking inside one of those notification messages. You can see here there is the link that points to where to get the data. In this case, the Danish server is publishing links which point back to their original data supply endpoint, which requires an API key to access. So as a work in progress, we're trying to understand how we can make FEMDI make this work a bit better. Should we have a FEMDI community broker that can subscribe to messages and rewrite the URL and deal with the authentication for you? We'll work on that, but suffice to say that right now, if you've got authentication in the way, you need to have an API key in order to resolve this. Next. Because if you just take that link and do it, you get an error status code when you try and do it. Like I said, some IT stuff isn't very exciting. It just says you're not allowed. Next, please. And then if you put that API key on the end, you can now download the data. And I just remind us that FEMDI Gateway enables the same API key to be used across all data services from all members. so that and it also allows you to expose data in an unauthenticated as way. But we're going to talk about access control a bit later on. Okay, next, please. So on to authentication. Thank you for staying with me so far. We're cracking on. This is becoming probably less and less interesting, and it's more and more invisible, and you shouldn't really see any of this stuff if you're just a normal user. But it's important that you know it's there. So with this part, we are going to see how your data service could be protected behind the FEMDI gateway. Look at authentication and quality of service enforcement. So we're going to start with a failure. We're going to see unauthorized attempts to access data, and then we'll see how you get an API key and so on. So next, please. Okay, so like I said, this is the behind the scenes boring stuff. Look, here we are, we're trying to access the Danish data. If you look at the URL at the top line in the browser bar, we're accessing the Danish data. That needs an API key, and it says, no, you're not allowed. You don't have an API key. And then we think, oh, well, okay, let me go to FEMDI and see if I can access it from there. Jane, if you do that for me. Here we see the browser bar is API 6 UMIT FEMDI, blah, blah, blah. So this is trying to access the Danish data through the FEMDI gateway. And it still says, no, you're forbidden, because we've set up FEMDI gateway to put authentication in place. So for this data service, you need to be a registered user. You'll also be pleased to see that FEMDI provides you with a little bit more useful information about what to do when you can't access stuff. It gives you a link to follow to find out how you register and where you register and who to get in touch with. So why would I? FEMDI also supports unauthenticated access, and we saw that when Mikko was browsing earlier, he didn't have to use an API key. And you might ask, why does FEMDI force users to register? That's so that sometimes we have data policies that require that, but it also allows FEMDI to collect better usage metrics. We know who they are, and this helps us better understand how or why they might be using our data. And it also means we can get in touch with them to let them know about any upcoming service issues like planned maintenance or upgrades. Next, please. So I'm following the link. And here it is. It's this prototype developer portal. I did tell you it was simple. It does work though. So we're going to press log on or log in. And then we are going to authenticate with my third-party identity provider. In this case, it's GitHub. Click. And then it takes me to the authorization screen. So those of you who have logged on to web applications using your Google account, you remember that you need to authorize the application. You need to tell Google, or in this case, GitHub, it's okay that this application knows who I am. And in this case, we are wanting to find the email address of who's authenticating. And we use the email address to know who we're talking to. So click. Okay, that was it. That was all it took, 2 clicks. And I have created a new account in FEMDI. Now I can get my API key and I can use that. I'll just remind us all that that API key can be used for accessing all of the data services that we're publishing. And even if there's a data endpoint which is accessible through unauthenticated usage, if you put your API key in, you'll get a better quality of service. You'll get a bigger rate limit. Okay, next, please. Okay, so I put now that I've logged in, I've created my thing. I can see all of the endpoints that I could access. And these endpoints should also be visible in the Data Explorer and the catalog. We call them routes. That's what API 6 calls them, but basically there's just the list of data service URLs. Okay, so next, please. Here, so remember before we couldn't access because we didn't have an API key. Now you can see in the top bar, I'm trying to repeat that query. This time I put my API key in place and we get a successful response. This is, Mikko showed you nice pretty graphics. This is actually the machine readable stuff that gets returned when you query an EDR endpoint. So API keys, easy to get hold of, then you can access the data. Next, please. So the dev portal is being developed in GitHub. There are links on that in the EU Rodeo project. You can see the code, dum-de-dum. Not much more to say on that. Next up, please. So now we're going to look at quality of service. We're using this API 6 gateway to make sure that we don't overload the data services that we publish ourselves. So here we've set up an example. It's a contrived example using creating a route for the FMI server. So as an unauthenticated user, the rate limit is set to 2 requests in 100 seconds, which is pretty small. So if I clicked on that, you can see in my HTTP response headers, that's the bit on the right-hand side, I have 2 requests left for the next 100 seconds. That's not going to last me very long. So click, and suddenly I get forbidden again. I can't access the service anymore because the rate limiting has prevented the requests going through to the FMI server. I will say that 2 in 100 seconds is artificially low just for the example. We wouldn't do that in real life. So this time, the information that we're providing to people is that either slow down your rate of access or authenticate yourself to get a better rate limit. So if we go next slide, please. So now, this is just using a developer tool called Insomnia. So apologies for the dark screen. We're using the same server. This is the finished server. This time we are including the API key. You can see *** in the middle. We're providing the API key as a header this time. And now you can see we get that green HTTP 200 response. So that's a response which says, yes, it worked. And you can see the response headers saying that my rate limit is now 100. I have 97 left for the next 43 seconds. So just by authenticating, the API gateway is giving me a better quality of service. And there's a number of other things that we can configure as well. Now, it's important to say, UMetNet, that's us. We're in charge of setting the rate limits that we want for different data sets. And I'll just remind us that we will be setting best quality of service for us as members to make sure that we always get prioritized access. Next, please. So now we're just into some FEMDI management stuff. We're going to talk about how we publish metadata, how we publish, how we actually manage the deployed instances of the FEMDI gateway, and how we manage users. I guess that you guys are probably getting a little bit tired of listening to me, so I'm going to rattle through this as quickly as possible. So next slide, please. So when it comes to configuring the API gateway, remember we have instances deployed on a number of different platforms. We're using this tool called API 6. The configuration of that is quite complicated. So to make it easy, we've designed a very simple configuration file. That's over on the left-hand side. In the black screen, you can see how simple it is. That's the bit in the top part of the black screen. And we save that in GitHub. When I make a change and commit a change, then that triggers a GitHub action or workflow, which in this case uses the some Python code that we've written, generates the detailed API 6 configuration, determines the target platform for this configuration, and then uses the API 6 command line interface to send that new configuration to the API 6 instance, and then it gets updated. So it's as simple as that. All I need to do is edit a file, commit a change, and the job is done. This is, I think, a very interesting way for us to manage services without having too much complexity, and it allows us to keep those secret credentials, like the admin passwords and stuff for the API 6 gateway credentials, gateway instances. We can store those as secrets in GitHub, which is a very clever way of hiding that information from everybody. Okay, next. When it comes to publishing metadata, we can use another mechanism, a very simple mechanism. Again, we're using GitHub Actions. In this case, where we have a simple metadata control file, which is simpler than the full record. We generate the WIS2 discovery metadata and the notification message. We deploy the discovery metadata record onto an inbuilt part of GitHub called GitHub Pages, which basically is a web server. We publish the notification message to a cloud-based MQTT broker that was free for me to operate. And then the global broker has already subscribed to that. So it automatically gets that notification message, validates it, and then pushes the notification message to the global discovery catalog, which then looks at the content and says, aha, I need to download new metadata from where I put it. It gets a copy, validates it, and inserts it into the repository if it's valid. So the useful thing here is that this was free for me to do. It was no code. It doesn't require an expert or a coder or new systems or whatever to make it work. Next, please. Okay, and then finally, because I thought you'd be running out of steam after an hour, just let me tell you that there's a bunch of administration tools that we built around user management, key management, all the stuff that you need to do to keep this kind of stuff in check. You can log on with your admin password if you are one of our system controllers, and do what's necessary. My little man here says, gosh, what a long password, which is a cue for me to say, you know what, there will be cybersecurity policies in place about how we manage this stuff. So part of the policies that were built as part of the team and sign off through staff and the other places in UMen will be those cybersecurity passwords, cybersecurity policies. Okay, next up. Finally, it's time for a break. Do we still have time for 20-minute break?
Yes,
right?
Jeremy.
Yes.
We have time.
Super. So that's all, folks, from me. Except if you have any questions. Let me just recap. We started with much more interesting stuff where you actually saw data happening, and then finally moved through the boring brown stuff that needs to happen, because if it doesn't happen, nothing works properly. So thank you for sitting with me. Hopefully you take away that we have running stuff. We've had some good design decisions. We've implemented it and tested it, and we are spending your money wisely and delivering. We're on course to deliver value through this radio project. So with that, I hand it back to the chair, but I am poised for questions if we want to do that now.
Yeah, thanks, Jeremy. Yes, so we have now seen that there is stuff behind the scenes that's working. It's a lot of machines talking to machines, but through a user interface, we can also see the data, so that's good. I think what we do is we take a few minutes for questions, if there are any, and then you will see on this slide that we would very much like you to enter a letter A, B, or C into the chat. But before you do that, are there any questions or comments to the presentations by Jeremy and Mikko?
There are a couple of comments in the chat.
Yeah, I can see that. It's Charlie saying Jeremy raises an important point to think about in EU and domestic data policy. Some of these policies insist anonymity as part of open for reasons that I'm happy to talk about. Okay, that is problematic, but for us as a community, Willie answers that one. It's about I see no issues with having better rates of access for registered users, but these are conversations we can have with our EU contacts. So, Willie, can you perhaps explain? Is it fully up to us to decide who is going to have priority and high data rate access, or is there something at all in the regulations that says something about this?
Yeah, I mean, there's nothing at all in the regulation that talks about open means anonymity. The only, I mean, the question we would we can have with our EU contacts is whether they would be opposed to any system where, you know, users had to register to use it. But if we want the insight, then we'd need registered users. I mean, Jeremy's suggesting that you could have different rates depending on whether you register. Might be something that we could explore with our contacts, because as Jeremy made the point, these APIs can handle hundreds, thousands of requests. So people that don't want to register could still probably get some of the stuff they wanted. But I think this is basically it's about working out what we can't do. There's certainly nothing in the regulation about users having to be anonymous.
Good, thanks. Then I see Tarja.
Yes,
Yes,
I think in the directive it says that you'll have to inform that what kind of level of service you are giving, and then to apply to what you are stating, what you are going to give. So they are not setting specifications, but they are asking you to provide the information for the users that what kind of service level you are giving.
Good, and actually I think that we will come back to a bit later in the afternoon, the minimum level and how to announce that level. So we will discuss that later today. Any other questions or comments at this stage? If not, we will have a 20-minute